Stephen. Oh, let's start. Enter the next level, migrating to cloud-native platforms. Oh, that's the wrong key, so that's the right key. We will talk about cloud-native in general, API gateways, service meshes, DevOps, and observability, hopefully in 25 minutes, so we have to be fast. Cloud-native, a term consisting in the whole atmosphere. Actually, everybody's talking about cloud native, but what does it really mean? Cloud native talks in general about distributed systems. And the distributed system is a system in which individual computers are connected through a network and appear as a single computer. This is what Scholl and Svensson and Jaworczyk pointed out in their book, talking about cloud native. We also think about the CAP theorem when we think about cloud native. We have to talk about data, what it really needs. It's talking about consistency, high availability, tolerance to network partitions. So mainly we only get two of them right away. So normally we have consistency and high availability. And the third factor of cloud native is the so-called 12-factor app. When we build apps, we have to deal with certain kind of steps regarding the domain of the app or the factor of the app. So we have to think about one code base, track them in version control. We have to think about configuration, the storage of configuration in the environment. We also have to think about strictly separate build and run stages. And what's really, really important, we have to think about that every service manages its own data. So we have data isolation, concurrency, disposability. We also have to talk about the logs so that they are really event streams and not in the monolithic way. We already know when we think about logs. So these factors are relevant when we talk about cloud native apps. When we think more about cloud native, we think about containers. So this is something everybody knows. So normally we put our applications into a container. The next thing is about the orchestration of all the containers. So we have to think about provisioning, deployment, resource management, health monitoring, scaling, providing of mapping to connect to networks, and load balancing. So we have this whole orchestration type of thing. And to do this, we are normally forced to use something like Kubernetes, which was open sourced by Google in 2014. And at this point of time, every cloud vendor offers some concrete Kubernetes offering. So everybody can handle in an easy step dealing with Kubernetes. But what is Kubernetes? In Kubernetes, we have normally a pod, a service, we have replica sets, and these are the easiest things to talk about when we talk about services. So when a request through the service comes in, it is routed through the containers, built up by a replica set, and all in all, this layer is just a deployment. So with these replica sets, we are able to roll them up, monitor them, and update the pods when we talk about the deployment. But what is also cloud native? When we think about cloud native in a more deliverable way, we think about lift and shift. So we think about infrastructure as a service, platform as a service, and every interested user of a cloud native environment has to think about, do I need infrastructure or do I need a real platform as a service? With a platform, we have more bindings, more maybe vendor lock-ins and so on. And when we think about just the infrastructure, we are more on the deepest level of a cloud provider. When talking about the cloud native phase again, we think about application modernization. And why do we think about application modernization? We think about faster deployments. We have maybe some components that need to be updated more frequently, or we have to scale the components we use in our application. Or sometimes we think of a technology change so that components can be developed in different technologies. And mainly the code base is too big and too complex because we have normally a monolith, to be fair. How to get into this application modernization, we have to talk about patterns. There are two patterns available. We have the strangler pattern and the anti-corruption layer pattern to provide all these things to move the application to a modern way. When we look at the strangler pattern, we see that it's possible to do a certain kind of service into put a service into a microservice and use the strangler pattern to gain access to the new microservice and to move the application to a modern world. Microservices are a part of the cloud native. So they are small, they are loosely coupled, and they are always focused on area of functionality. So they always do certain little kind of things. They don't do big service things. They just focusing on a certain service. When we think about microservices and controlling them, we always came up with an ILD world and think about an API gateway to get to these microservices. And when we look at an API gateway, it's always a door that opens and closes all the time and give access to the services behind the door. To understand API gateways, we have to revisit patterns again. The oldest pattern available to deal with API gateways is the Fascade, developed by the Gang of Four. And a Fascade is an object that serves a front-facing, interfacing mask, masking more complex underlying or structural code. So we just mask something which is more complex or structured. When we go more into the nowadays, we see a new definition in comparison to the Fascade. It's the API gateway definition by Chris Richardson, where Chris really focuses on the meaning of an API gateway. What does it and what does it not? In the simplest way, just proxying and routing to an appropriate service. But it can also do certain kind of other things when we look later at. So an API gateway is a solution for routing. This is the easiest part of an API gateway. We put this in between the services and the clients and see that it's just a routing through the services, through the gateway. The gateway knows where the services are and the client just calls them via the gateway. The second part is a gateway can also be a solution for aggregation, which means the gateway knows where to build up the request by just getting a call from a client and give them a response. We see on the number 4. So the gateway combines all the services to one response. But this is in some cases an anti-pattern, because you now have all the business logic in the gateway. So you can't just easily replace a gateway when you will do this in that way and using an aggregation pattern, you always have to rebuild the whole business logic revealed in the API gateway. So when we think about this aggregation, it is more or better to use an aggregation service, which combines the services afterwards and give the response to the gateway, and the gateway gives it away to the client, and the client can receive it via the gateway, where all the other things a gateway can do, we see them later, are placed. But the aggregation part is an extra service to be more safe regarding the architecture. And the gateway can also be a solution for offloading or so-called cross-cutting concerns. These offloading features are authentication, authorization, rate limiting, caching, compression, SSL overloading, logging, and monitoring. So now every service has to deal with authentication, authorization. It all can be done in the gateway, which makes it easier for the developer to focus on the real meaning of the service, not to think about, oh, I have to handle the authentication or the authorization. Oh, I have to think about circuit breaking and so on. So the developer is focused on the service, and gives value to the service again to be more convinced of doing the right thing with the service. This API gateway can come into two variants, as an ingress or an egress when we look into Kubernetes. An ingress deals always with the traffic which comes into a system and do all the tasks like routing or offloading. And when we have an egress, this is just for control the traffic exiting a system. So when something goes in the other direction, not back to a client, more to the system of records. And again, we have this egress gateway, which just controls the traffic. When we get more and more into this Kubernetes kind of thing or cloud native thinking, we have now the gateway, which covers the front door, or the ingress, which covers the incoming traffic. But what is with the connectivity between the services in these cloud native architecture? So when we think about the connectivity between the services, we have to think about a service mesh. A service mesh comes up when we have two types of services in maybe two different languages like Java or Python, and they communicate with each other. When we think about doing this in Java and Python, we have to build up communication code in each of the languages. When we're bringing the pattern of a service mesh, it's just a sidecar or a proxy in which the communication code is revealed. So the services don't know anything about the communication code between the two services. They just have all the meanings for their service, not this communication code between the services. This is handled with the proxies. And when we think about this in a bigger way, we have a control plane overall, and we have these services within the data plane, and the services communicate via the proxy, and the proxy communicates via the control plane to give a whole overview over the whole connectivity of all services in this mashup. So every thing within this cloud native app is handled via the control plane. So every communication between the services is really controlled by this control plane. So in the use cases are traffic management, failure handling, security, tracing, and monitoring. All this can be placed within the proxy beside the service. Maybe this proxy is also called sidecar when we are in the Kubernetes world. So we all talk about technology all the time. Everything is about technology. We have API gateways, we have microservices, we have service meshes, and so on, so on. We have containers, we have Kubernetes, and so on. But all this needs another pattern, which is called DevOps. Now we can't talk about developing something and throwing it over the wall and don't have any responsibility about it. We have to think about in this DevOps way and say, okay, I develop it and I bring it to the operation together with other operation guys. And this is a really broad concept with goals. It should really improve the collaboration between development and operations. It also should improve the deployment frequency. And behind that, we achieve faster time to market. And hopefully, our failure rate gets lower with new releases. And maybe we can shorten the lead time between fixes. And hopefully, we improve mean time to recovery when a service is not available. When we talk about the DevOps, we always think about, yeah, we do this all the time. We are really doing DevOps, but that's not really true. When you talk about DevOps, you have also to think about the CALMS model. But what is the CALMS model? The CALMS model stands for collaboration, automation, lean principles and processes, measurement, and sharing. So DevOps talks about the collaboration between developer and operation. That's good. But to achieve all the goals of DevOps, we need automation. We have to automate nearly 80% of the whole life cycle we use. And everything should be done with lean principles and processes. So it should be agile, as normally someone would say. To be fair, agile is always now a buzzword. What we need also is measurement. We have to measure what we are doing. So we have to really measure the times we need to recover services and so on. And the last and important part of all this is sharing. Collaboration is one thing on one side, but sharing is really needed. I have to share the information and the knowledge I know with my colleagues regarding if they're developers or operation guys. We have to really talk about. Because when we look at a real simple CI/CD workflow, we see how complex all these CI/CD flows and processes are getting when we think about moving to a cloud-native world. We have this code complete, we have to push it into Git, but we have to security scan the images we build when we build a container and so on. We have to test the configuration. Maybe we have a staging to deploy it to a staging server, to a staging Kubernetes, do testing, think about releases. Hopefully telemetry is okay. Then we can do a rollout, and hopefully we don't come to a rollback. So hopefully we have a release, and when we don't have any stages, what we now can do is think about canary testing. And why? Because we're using something like an API gateway, we can also think about doing this canary testing by using the API gateway. So there's something like an offloading in some cases. This canary test can be an offloading. So the gateway can handle the requests to do canary tests so that we can test new services that would be released so that we can really have a good release pipeline and so on. When we talk about releases and all the things, CI/CD pipelines, the last thing we have to think about is observability. What really means observability? Observability is all the data is made available that we can monitor, and in the last step analyze the monitoring. But first of all, we need to get the data available. So we need to collect all data from the build pipeline and from the releases and so on. So it is not enough to do just the so-called thing monitoring. It's really important to do observability, which means to get the data or to achieve that the data is available. And after having monitored the available data, we have to do real analysis on the data to be aware of what our application is doing all the time. And maybe to get in a process of a data-driven development and so on. And this is the only value principle. It doesn't really, or it isn't enough to just say, oh yeah, I'm using a monitoring solution and we all have an elk stack and so on. You really have to think about the data at first. What data would you like to see? And then how to monitor it. And then the most important part is to analyze the monitored data. And that's all on our journey to cloud native. Thank you very much. It was a real pleasure. Hope you had some fun time and see you soon.